Alright, so now we're going to do a homework check on section 7.4, section 3, as well as 7.5, section 1. So starting with 7.4, section 3, we only had a few of these to work with. We're doing 2 through 5 in working the proofs. So number 2 here, we've got if T then F or F, not F and F, therefore not T. Well, very simply on line 1, you can see a tautology there, F or F, so this becomes if T then F from line 1 through tautology. And then on line 2 there's also a tautology, F and F, so that can become not F from line 2 through tautology. Now it's just a simple matter of modus tollens. If true then false, not false, therefore not true. 3-4 modus tollens. Very easy. With number 3, we've got if G then E, if H then not E, therefore if G then not H. So our initial thought here would be some kind of hypothetical syllogism. The problem is that what we'd need would be if G then E, if E then not H, therefore if G then not H to make a hypothetical syllogism. So how can we get if H then not E to become what we need? Well, that's pretty easy. If we use transposition, H then not E would become not E, then not H. And then for simplicity's sake, we'll simplify that not E through double negation. It becomes E then not H, 3 through double negation. And so now we have exactly what we needed, right? If G then E, if E then not H, therefore if G then not H from 1 and 4 through a hypothetical syllogism. Number 4, we have S if and only if Q, not S, therefore not Q. Alright, well obviously we can't do anything with the triple bar, the if and only if, so we're going to have to use material equivalence on that. So S if and only if Q is going to be exactly the same as if S then Q and if Q then S. From line 1, material equivalence. Now we want not Q, and I can see it right here. If S then Q, not S, therefore not, if Q then S, not S, therefore not Q, modus tollens. So we're going to need to do a simplification here. If you want to do a commutativity, you can do that first. I don't think it's necessary. So I'm just going to take the if Q then S from line 3 through simplification. And so now if Q then S, not S, therefore not Q, from 2 and 4 modus tollens. And finally, that brings us to 5, which is not N or P. If N, then P, then T. Therefore, T. All right. So looking at this one, it looks pretty simple again. If N, then P, then T. If we could get N then P, we could set up a modus ponens that would give us T. So is there some way to turn not N or P into if N then P? Yeah, material implication lets you do that. So here on line 3, we'll take the not N or P and we'll make that if N then P from 1 through material implication. And so now lines 2 and 3 give us our answer through a simple modus ponens. Okay, so those are pretty easy, and hopefully you found them to be so. So now we're going to go ahead and turn to section 7.5 7.5 section 1, and here we only had to do 3 through 5, and these are working with conditional proofs. So at number 3, we have if G then T. At line 2 is T or S then K. Therefore, G then K. Alright, so to work a conditional proof, again, you're going to start with the conditional statement in your conclusion here. Then you'll take the antecedent, and that'll become line 3. We're going to put that G, and then this is ACP, assumed conditional proof. From here on, everything we do is going to be indented to that line to show that it's based upon the assumption. But from here, we just go ahead and solve, and the idea, again, is to try to get to the consequent, which is K, in order to conditionally prove this. So, what I see now that I've got the G in there is that 1 and 3 will make a modus ponens. If G then T, G therefore T. 1, 3 modus ponens. And now I want to get to that K, so we need T or S. So I'm going to take the T from line 4, use addition to add an S. And now 2 and 5 make a modus ponens. T or S then K, T or S therefore K. Alright, so 2 and 5 modus ponens. And so now we've gone, from the G to the K, from the antecedent to the consequent. So we'll go back over this way, alright, keeping those indented. We'll go back over here and we can conclude G then K from 3 through 6 CP conditional proof. Number 4, we have G or H then S and T. Line 2 is T or U. Then C and D. Therefore, G then C. Alright, so again at line 3 I'm going to start by assuming the G, ACP, then we indent for the rest of this. Alright, so I need to find a way of getting to C, which is down here somewhere. So the first thing I can do, you've got G, so let's use addition to make G or H. Line 3 through addition. Now lines 1 and 4 make a modus ponens. If G or H, then S and T, G or H, therefore S and T. 1 and 4 modus ponens. Then we can take S and T and simplify it to T. You could use a commutativity in there if you're more comfortable doing it that way, but basically we just need the T. Now we want T or U, so we'll take the T from 6, use addition to add the U. And so now 2 and 7 make a modus ponens. T or U, then C and D, T or U, therefore C and D. 2 and 7 modus ponens. And then we can just simplify C and D to C. Okay. And so we've gone from the antecedent to the consequent, from the G to the C. So now coming back over here, we'll put our conclusion, G then C, which is from 3 through 9 through CP, conditional proof. And finally, the last one, number 5. We've got if A, then not A or E. Line 2 is, no, that is the only line. So therefore, A, then F. Okay, So now we've got A, then, not A or E, therefore A, then F. So we're going to start with the antecedent, which is the A. Again, ACP, assume conditional proof, then we'll indent and start solving from there. So 1 and 2 would make a modus ponens. If A, then not A or E, A, therefore not A or E. 1 and 2, modus ponens. Now, not A or E, is there anything we can do with that? Well, not A or E could become not A and not E from De Morgan's. Now, we could simplify that to not A. And then, since what we want to end up with is the F, right, we're going to have to add that in. So we'll make that, let's go back to the line 2A, and we'll add in the F, A or F, through addition. And now you've got 5 and 6 make a disjunctive syllogism. It's either A or F, it's not A, so it has to be F. 5 and 6, disjunctive syllogism. So we've gone from the antecedent to the consequent, from A to F, so we can conclude if A then F, based upon 2 through 7 as a conditional proof. All right? So that's basically the way that it works. So hopefully, again, you got all those right. Before we go today, I just want to give one other thing here I want to show you. We've been using these traditional and typical symbols here. We've got the tilde for negation. We have the dot for conjunction. We have the wedge for disjunction. The horseshoe for conditional. And the triple bar for biconditional. There are other symbols that are used, and when I've made the exam, because of the way that the computer is, a few of these symbols I can't really do on the computer, so I've used an alternative. So I'm going to give this to you on print later on, but I also want to give it to you now. The negation is basically the same, the tilde, except that in the print it kind of looks a little bit more like a negative sign like that. The conjunction, instead of the dot, I've used on the exam the ampersand, which again implies the idea of and. The wedge can remain the same because you can always make a lowercase v. One of the other symbols that's used for a conditional instead of the horseshoe is the arrow. And so I've used the arrow on the exam. And the biconditional is a triple bar. We don't have a triple bar on the computer, so I've used just an equal sign for that. So again, I'll give these to you on print on the computer as well. But I just want to show this to you now so that when you go to take the exam, you will know that this is the symbolism that I'm going to be using on there, simply because it's what works with the computer program that they've given me to work with. These are the symbols I have. I don't have, these symbols that we've been working with. But again, there are a number of different symbols that are used in logic to symbolize these things, depending upon whose version of logic you're working with. So we're just going to switch over to these. So again, real quick, for the exam, the negative is going to look more like a minus sign. The conjunction, the ampersand, the disjunctive will still be the wedge. The conditional will be the arrow, and the biconditional will be the equal sign. All right. So again, if anybody has any questions, let me know. But otherwise, have a great day.